Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study some of the about moment of inertia of a semicircular section. Here, moment of inertia of a semicircular section, it is having a radius of r. Radius of the circle is r, and d is the diameter. And ABC is actually here the AB arc of the circle, semicircular section is ABC, and we are going to find out the moment of inertia about AC, that is the base AC. And here IAC moment of this, it is a semicircle. We know the moment of inertia of circular cross section, solid circular cross section, that is pi d power 4 by 64. This is the moment of inertia of a circle, solid circle. But here it is the semicircle. So what will happen here? It becomes half of the solid circle. So semicircle, the semicircle moment of inertia, that is IAC, here it is equal to, that is half of IC, that is 1 by 2 of IC. That 1 by 2 of IC, that means here 1 by 2, that is pi d power 4 by 64. That means here that is pi by 128 d power 4. That is the moment of inertia about C, circular semicircular section. So this pi by 128, if we make it simplification and if we do calculation, that it becomes as 0.393 r, and substitute d equal to 2r, then what will happen? That it becomes pi by t 0.393 r power 4. That is pi by 128 times, here it is pi by 128 times d equal to 2r, that is 2 power 4 and r power 4, and cancel and simplify, then it becomes 0.393 r power 4, that is IAC. IAC equal to 0.393 r power 4. So what is that area here? The area of the semicircular section is half of the circular section, and half the complete circular section, that is a pi r square. Area of the circle, area of A of circle equal to pi r square. Then what is the semicircle? Area of A of semicircle, equal to 1 by 2 pi r square. That is nothing but pi r square by 2. This is 0.393 r power 4 or pi by 128 d power 4, pi d power 4 by 128. It is better to remember, we can remember easily. We know the circle pi d power 4 by 64, and half of the circle is the semicircle moment of inertia. Now the moment of inertia, further the distance between, we have to find out, if we want to find out the moment of inertia about G, that is the centroidal axis IG, then by using the parallel axis theorem. What is the parallel axis theorem here? IAC equal to IG plus area and times, what about here, h square, means h square, h square, where h is the, IAC is the parallel, h is the distance from centroidal axis to where the reference axis is there, base axis, and A is the area of the circle, and h is the centroidal. What is that? H is the centroidal. Here in this figure, it is symmetrical about vertical axis YY. So symmetrical about vertical axis, we have to find out parallel to x axis passing through centroid. The centroid is located at a distance of 4r by 3 pi. That is the h. So that is the distance between the center of gravity of the section and the base, h, that is equal to 4r by 3 pi. Now we want here, first of all, we have to calculate what is the IAC. We calculated here, that is IAC, area of the section. IAC equal to IG plus H square. What about IG? Centroidal axis, IG equal to IAC times AH square. Okay. Now Moment of inertia of the section passing through center of gravity and parallel to x axis. Then from the equation IAC parallel axis theorem, IG plus AH square. Then what about happens IG about centroidal axis, IG equal to IAC minus AH square. What is that IAC? It is the base. About the base, just now you calculated that IAC equal to 0.393 R power 4. Or what is that? Pi by 128 D power 4. That is 0.393. And area is pi r square by 2. Substitute this IAC and pi r square and h equal to 4r by 3 pi in this equation. Then we will get it IZ, the moment of inertia of centroidal axis of the semicircle. It will be around, this is the AC. Okay, this is the centroid, this is XX, that is centroidal axis passing through. We know this IAC, we want IG plus area into H square. Okay, now what is IAC? Pi r power 4 by 8 r 0.393 r power 4 r power 4. Substitute here, and pi r square by 2 a equal to pi r square by 2 of pi r square, h equal to 4r by 3 pi whole square. Then if you make it further simplification, that IZ comes as 0.11 r power 4. This is the moment of inertia of a semicircular section. Okay, is the moment of inertia of a semicircular section. So for moment of inertia of a semicircular section passing through the axis, centroidal axis, moment of inertia of the section through its center of gravity and parallel to x axis, that is 0.11 r power 4. What is IAC? That IAC equal to pi by 128 r power 4 and h equal to 4 r by 3 pi. Whatever area of pi r square 1 by 2, that is pi by 2 r square. That is IAC H. Now IZ is what we got. IZ centroidal axis, moment of inertia of the section through its center of gravity and parallel to x axis, that is IXX center of gravity, that is 0.11 r power 4. Now what about, if you want about vertical axis YY, what is the centroid? What is the moment of inertia about vertical axis? How to find out the moment of inertia about vertical axis? Let us apply the concepts of here, concepts of the semicircle. Now this is centroidal axis, this is the symmetrical about axis YY. About this axis, we want about this YY axis, we want moment of inertia about YY. So how to find out moment of inertia about YY? Okay, so it is also, what will happen here, it is also semicircle. Then IG, what is IAC? No, we can call it as, it is IAC means off of the circle. It is about this circle. Yes, let's think about this IYY. We know that how to make it now. IYY is passing through the centroidal axis. Am I right? Yes. Take a reference axis. How to apply the concepts of this parallel axis theorem for semicircular section. Okay, now IYY, how it comes? IYY equal to about this centroidal axis IYY. Yes, let us begin. About this centroidal axis IYY equal to IGYY parallel to centroidal. Yes, IGYY plus area times h square. This h is parallel to y axis. Now this is h equal to, from this reference axis bar y. Yes, that is okay, that is h is the parallel to the distance from this. What about IZYY here? This IGYY we want IYY. Here, as we have studied that IAC equal to, what is that IAC equal to? IAC is nothing but, it is here in this section, IAC, we want about this semicircular centroidal, okay, that is pi by 128 d power 4, or what is the value here? Pi by 8 times r power 4, okay. This is the value we got. What about IGYY? Want IGYY. What about area? Now H. What is the H meaning? The meaning of H, you have to go to concepts. H is the distance. What is the H is? Distance from, okay. This H is passing through. What is the passing through? Centroidal. This H becomes 0 here. And H becomes 0, 8 times 0. Okay, there is no distance between centroidal axis and its centroid here. It is passed, the YY axis is passing through it. Okay. Now we want IGYY. This is passing through centroidal axis. This IGYY. Don't get confusion here. This is IGYY I am keeping. So this area times this distance. This is 0 distance because both lines are passing here. The distance between centroid and the reference axis. Here the axis is YY, centroidal, and it is passing through centroid, that is 0. A times 0, it becomes 0. Then what about IGYY equal to? This IGYY equal to IYY. That IYY equals nothing but IAC. So here that is pi by 8 times r power 4. That pi by 8 times r power 4 is nothing but 0.393 r power 4. Okay, this 0.393 r power 4. Okay, like that we have to calculate the moment of inertia about the axis. Now we are going to solve the problem for this semicircular section. Okay, determine the moment of inertia of a semicircular section. This is the semicircular section. Okay, semicircular section AB. As we have mentioned here, it is ABC. As we go for ABC, semicircular section of 100 millimeters diameter. The diameter is 100 millimeters. Diameter is 100 millimeters. About its center of gravity and parallel to XX and YY axis. Yes, parallel to XX and YY axis. This is XX passing through center of gravity, and here it is YY. How to calculate? Now parallel to XX axis, we know that IXX equal to, we already derived expression, that is about XX parallel to that, that's 0.11 r power 4. So this is what expression is, 0.11. This is the G is passing through what, parallel to XX axis. So that is 0.11 r power 4. So we can directly substitute here 0. In the place of r, diameter equal 100 millimeters. What about radius? That is 50 millimeter. That substitute here 50 power 4, then it becomes 687.5 times 10 cube millimeter power 4. That is IXX. This is axis passing through center of gravity parallel to XX axis. XX axis. Now, this is the direct expression. Suppose if we don't know the expression, what to do? Then we have to go for that expression concepts. The concept is that, what is another method? Another method. What is the another method? The another method that, what is the IAC? What is the IAC equal to? Semicircular section, pi by 128 times d power 4. We get this value. What is the diameter? 100 millimeters. What about area of the semicircle? Pi by 2 times r square. Pi by 2 times, what about r? 50 square. We get this value. What about h equal to? Here it is 4r by 3 pi. H is the distance from at 4 times 50 by 3 pi. H value can be known. Now what is the value here? What we need? IAC equal to IGXX plus 8 times h square. Substitute here a value, here a, h and IAC, then IGX will come directly, that is 687.5 into 10 cube millimeter power 4. Now, we want moment of inertia of the section about its center of gravity parallel to which axis? That is y. Alright. For this y axis, as we have derived already expression here, pi by 8 times r power 4. What is the pi by 8 times r power 4? That is nothing but 0.393 r power 4. So here we substituted here, that is Iyy equal to 0.393 r power 4. 0.393 times, what is the r? 50 millimeter power 4. That is 2456 into 10 cube millimeter power 4. 2456. Yes, here it is 687.5. So here in this case Iyy is greater than Ixx. How we got this 0.393 r power 4? We already expressed, derived expression. Okay, one more time, we will find out this, how we will going to get it. This r parallel to y axis. This is the centroidal axis passing through it. By using parallel axis theorem about y, we want, what is that y? That Iyy equal to, okay, how to get it this Iyy? Yes, this Iyy equal to, about C, the semicircular section, okay, or one more thing, that is better here, passing to centroidal axis, no? So IAC, this IAC equal to Iyy plus area times h square. What about IAC? This IAC means that is pi by 128 d power 4. That equal to Iyy, which is passing through centroidal axis. What about area? Pi by 2 r square. What about the h distance here? The distance from centroidal axis of the semicircle to this y. It is passing already. That means h equal to 0. That means this term completely 0. Then Iyy equal to pi by 128 times d power 4. So in the place of d, this is, if you substitute d equal to 2r, that is 2 power 4 times r power 4. This 2 power 4 and 128 will be cancelled. Then pi by 128, if you make it simplification, we get it as, that is 0.393 r power 4. That is Iyy. Okay, thus we have to make it the moment of inertia of the section about its center of gravity, of the section about its center of gravity and parallel to axis y. Okay, next, this is another problem we are going to solve here. A hollow semicircular section. It is a semicircle, the hatching area. We have to find out the center of gravity. We have to find out the moment of inertia about its base AB here. That is the point. A hollow semicircular section has its outer and inner diameters are mentioned here. 200 millimeters and 120 millimeters is shown figure. What is the moment of inertia about its base AB? Okay. What to do? We have to subtract the larger circle. We have to subtract the smaller circle from the larger one. Then you will get it this portion, that yellow color or whatever, this colored portion. Okay. What is that color portion? We got it. What is that IAB? Moment. What is that? We have to follow. What is the moment of inertia about its base, not axis passing through center of gravity. So the given outer diameter is 200 millimeters. That means outer radius is 100 millimeters. Okay, and inner diameter is how much? 120 millimeters. So radius is obviously it is half of that diameter, that is 60 millimeters radius. Capital R equal to 100 millimeters, small r equal to 60 millimeters. So what about the section about its base? What is that base equal to? Just now we calculated, there are IAB equal to, base equal to pi by 128 capital D power 4 minus pi by 128 small d power 4. Okay, for semicircle, this is pi by 128, 2 power 4, make it common, then capital R power 4 minus small r power 4. Then this pi by 128 times 2 power 4, it becomes how much? 0.393 capital R power 4 minus small r power 4. That is IIB. This is what answer the derived expression is. This 0.393 capital R power 4 minus small r power 4, We know that capital R is how much? Yes, 100 millimeters. Small r is 60 millimeters. Substitute here. We'll get it 34.21 times 10 power 6 millimeter per 4. This is the answer for this problem. Alright, in that manner we have to solve. But here it is mentioned only. Okay, what they mention here? They mention very simple, to find out about its base. Now we are going to make it another problem from this data. What is the data here? We have to find out the axes which are passing through centroidal axis here. What are those values are? How to make it? That is up to you. We have to solve. This is the problem. Okay, how to solve this axis? We have to passing through parallel to x-axis and parallel to y-y. So parallel to x-axis, what is there here? Our formula. What is parallel to x-axis? That is IGXX. That is IGXX. Here x-axis is passing through the centroid. Then what is the expression here? 0.11 times capital R power 4 minus small r power 4. That is XX. IGXX passing through parallel to XX axis. Here if we substitute, you'll get it IGXX. We want a center of gravity, that is IGYY, parallel to axis. Then what will happen here? That is the same as here. This is the answer, IGYY. So what will happen here? That is 0.393 times capital R power 4 minus small r power 4. That is IGYY. Now you may ask, now IAB, it is similar to IGYY. Yes, it is a semicircle, as we have derived expression here. That is 0.393 r power 4. If you have to make it subtract capital R power 4, capital R minus small r, that is 0.393. That means IAB, the axis which is passing through this IAC, that equal to, what is that conclusion is here? The conclusion part is that, what is the conclusion? IGYY, this YY axis, centroid, the moment of inertia about YY axis, that is equal to, what is that? That is equal to IAB. IAB is the base. Okay, now IGXX, this is IGXX here. We are talking in the problem, they did not ask. We are giving that, we are now base is over, that problem is solved. We are making another problem from this, out of this data. That is, suppose if they want to find out XX and YY, moment of inertia for this hollow circular section. For that we are calculating. For hollow circular section, passing through centroidal axis, center of gravity, parallel to XX and YY. Okay, for that, so IGXX equal to 0.11 times capital R power 4 minus small r power 4. Substitute capital R equal to 100 millimeters, so small r equal to how much? 60 millimeters. Then you will get at IGXX value passing through center of gravity parallel to XX axis, that is XX. Now YY, what is IGYY? That is 0.393 times capital R power 4 minus small r, small letter r power 4. If you substitute here, then what is the answer? That is 34.21 times 10 power 6 millimeter per 4. Okay, in that manner we can solve the problems. Okay, parallel to x-axis. So one thing we have to remember, that while solving these problems, we need concepts thoroughly. Basic concepts you should not forget. Those, unless and until you understand and remember, then only we can apply wherever requirement is there. According to data, based on the data, we can base remembering on understanding and remembering, not remembering and understanding. So point is that now we are going to solve some of the exercise problems which are related to this moment of inertia of simple plane figures. Now it's a simple plane figures. The problem 1. Find the moment of inertia of a rectangular section that is 60 millimeter wide and 40 millimeters deep. Here it is like that. What is the 60 millimeter wide and 40 millimeters deep? Okay, find it about its about its which point? The center of gravity. About the center of gravity here, XX, YY. These two axes are passing through center of gravity. So we already know that for this derived expression, it is the D and it is B. And when it is XX and it is YY. For this XX and YY, what is IXX equal to? We derived IXX equal to what? BDQ by 12. IYY equal to DBQ by 12. Similarly here, what is the D here? D equal to 40 millimeters and B is 60 millimeters. We want IXX. So IXX equal to BDQ by 12. What is the B substitute here? What is the B value here? 60, D is 40, cube by 12. Then the answer output is that 320 times 10 cube millimeter power 4. Next, IYY. What about IYY? That is DB cube by 12. DB cube by 12. Direct substitution. That's it. What is the D? D value is 40 millimeters. B is 60 cube by 12. That is 720 times 10 cube millimeter power 4. Which value is higher? Is this IXX or IYY? IYY is greater than the IXX. Why? D is less than B or B is greater than D. Width is more than D per depth. That's why IYY is larger in comparison to IXX. Okay, in that manner you have to solve. Now coming to next problem. How to solve the next problem? Find the moment of inertia of a hollow rectangular section. Hollow rectangular sections. These are the exercise problems. Hollow rectangular section. For this hollow rectangular section, it is D and here it is B. And it is D1 and here it is B1. Which is again passing through which axis? Passing through center of gravity. This is XX and YY. Okay, now here for all the sections about this center of gravity, if the external dimensions 40 millimeter deep, 40, it is the B, 30 millimeters wide, and internal dimensions are 25 millimeters D1 and here it is the B1. Alright, now what about IXX equal to for this type of section? Parallel to X center of gravity, about the section of center of gravity parallel to XX axis, that is BDQ by 12, BDQ by 12 minus B1 D1 cube by 12. Substitute here B value, that is 30, D value, that is 40 cube by 12 minus B1. Whatever B1 here, 15 times D1, 25 cube by 12. Then IXX value, it becomes answer, that is 140.47, 140.470 millimeter per 4. This is IXX. What about IYY? Yes, let us begin. Already we derived expressions previous sessions. That is DB cube by 12 minus D1 B1 cube by 12. Substitute here D, B, D1, B1. Then the answer becomes as, that is 82970 millimeter per 4. Answer should be obtained. Okay. This is IYY DB cube by 12 minus D1 B1 cube by 12. That is the second problem we solved. Okay, now third problem, exercise problem. Now find the moment of inertia of a circular section of the diameter. Yeah, having what is the diameter here? I have drawn more than 20 millimeters. Alright. Now here it is. The radius becomes how much? Radius equal to the diameter is, this is radius is 10 millimeter. Our diameter is 25. Okay, through its center of gravity. So for solid circular section, it is passing through what? Center of gravity XX. And here also YY. Passing through center of gravity YY. Now IXX equal to IYY. That equal to, in terms of diameter, it is pi d power 4 by 64. Substitute in the place of diameter. What is the D? 20 millimeter. That is pi d power 4. That is 7854 millimeter 4. Answer comes. This is IXX equal to IYY. What about according to perpendicular axis theorem about IZZ if you want? They did not ask. We are extrapolating. We are doing exploring. this problem to solve about IZZ. What is IZZ equal to? IXX plus IYY. That is parallel. That is perpendicular axis theorem. That means 2 times IXX. That means 2 times 7854. 8, 0, 6, 15. 15708 millimeter per 4. That is IZZ. 15708 millimeter per 4. This is the answer for IZZ. But here it is asked only the moment of inertia of the circular section of 25 mm to its center of gravity, that is XX and YY both are equal for this circular section because it is dependent on only single parameter, that is diameter. Alright. Now next one, third one. Next fourth problem. Calculate the moment of inertia of hollow circular section of external and internal diameters are 100 millimeters and 80 millimeters small about an axis passing through its centroid. Alright, again it is a hollow circular section. For this hollow circular section passing through centroid, how to calculate? Again we derived expression in previous sessions, that is IXX equal to IYY, that equal to pi capital D power 4 64 minus pi small d power 4 by 64. Now pi capital D, what is the capital D here? 100 millimeters power 4 by 64 minus pi small d 80 power 4 by 64. Okay, the answer will be obtained as 2.898 into 10 power 6 millimeter power 4. That is IXX equal to IYY. Okay, we want IZZ. IZZ equal to perpendicular axis theorem, that is IXX plus IYY. Here equal, that is 2 times IXX or 2 times IYY. Then you make it as 2 times 16, 9, 7. Okay, that's some 5.796 into 10 power 6 millimeter per 4. Alright, next the third problem. Now it is the find the moment of inertia of a triangular section having 50 millimeter base and 60 millimeter height about an axis through its center of gravity and base. So it is related to the triangular section formula. You can go for it about its center of gravity. We want about an axis through its center of gravity and its base. There is a triangle. About the base we want, if you make it ABC, about IAC, and another one is IG, parallel to centroidal axis, parallel to the XX base. So what about G value here? G is from here H by 3. Okay, we already derived in previous sessions expressions. By using those expressions you can solve this. What about the problems of, this problem? Alright, like that, this one also, it is a semicircular section. Whatever semicircular section, just now we calculated parallel to XX and parallel to YY. For semicircular section, ABC, what is the diameter here? Section having a radius. The radius was given here, 30 millimeters radius. What about IAC? This IAC equal to 0.393 R power 4. Now IG, parallel to XX axis, that is XX, that is equal to 0.11 R power 4. Okay. Or what is that here? Pi about its axis XX, that is IGXX is the 0.11 R power 4. Now we want IYY. IYY we already derived, solved. IYY equal to 0.393 R power 4. Substitute R equal to 30 millimeters, 0.393 times 30 power 4, then you get the answer. That answer becomes, you can see, choose, that is 381,330 millimeter per 4. And 0.11 if you substitute, that is 89100 millimeter per 4. Now here IGXX, here XX passing. Now here IGXX, IXX is smaller than IYY. Okay. So in that manner, in this session we covered what is semicircular section, what is a centroid, about passing through derived expressions about its base AC and parallel centroid about the section passing through center of gravity parallel to XX and YY axis with derived expressions, and solved exercise problems based on the derived expressions from the previous sessions. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.